Here we have pre-calculus problem. Okay, let's go to the question. Find the probability for the experiment of tossing a six-sided die twice. We have to find probability for this even. That is, the sum is even or prime. Okay, actually the six-sided die is nothing but the cube, like the one what we have over here. So here it will have six faces, and six faces will be numbered from 1 to 6. That is, the sample space is the sample space means a set which contains all possible outcomes: 1, 2, 3, 4, 5, 6. So this is a sample space. The six-sided die is tossed once. So we can write this is 6. So, and also for this 6, what is the exponent? Actually, we don't have any exponent for this 6. For any value, if there is no exponent, we can assume there is exponent 1. So this 6 refers to the total number of all possible outcomes when a six-sided die is tossed once. And this exponent 1 refers to the number of times a six-sided die tossed. So it is 1 time. So 6 to the first power is 6. So when a six-sided die is tossed once, we get 6 possible outcomes. That is the total number of all possible outcomes. But in our question, a six-sided die is tossed twice. Twice means the exponent has to be 2. Then 6 square means 6 times 6, which is equal to 36. That is, when a six-sided die is tossed twice, the total number of all possible outcomes is 36. To get probability for this event, first we have to write all the 36 possible outcomes when a six-sided die is tossed twice. Okay, now let me write all these 36 possible outcomes. Here I have written all the 36 possible outcomes when a six-sided die is tossed twice. Okay, now let's understand the outcomes. Let me consider the first outcome we have over here, that is 1, 1. 1, 1 means when the die is tossed for the first time, we get the number 1. So second time is also 1. Or we may get 1 in the first time, number 2 in the second time. So 1 in the first time, 3 in the second time. In this way, we write 6 outcomes in the first row. The second row, we get number 2 in the first time, number 1 in the second time we are tossing the die. So in this way, we have 36 outcomes. That is 6 outcomes in each row. So there are 6 rows. So this is a sample space. Okay, now our aim is to find the probability for getting a sum that is either even or prime. Okay, now let me assume A as the event of getting the sum as an even number, that is sum as even, and let B be the event of getting sum as a prime number, that is sum as prime. Okay, our aim is to find the probability of P of A or B, that is a probability of getting the sum as an even number or a prime number. So there is a formula for this one. There is actually it is P of A union B. For P of A union B, the formula is P of A, positive P of B, negative P of A and B. Actually, and means it's nothing but A intersection B. Okay, now we have to find the probability of event A, probability of event B, and probability of event A and B. So we have to simplify this. Okay, since the total number of all possible outcomes when a die is tossed twice is 36, we can write the total number of all possible outcomes in 36 for each probability. Let me write the stuff over here. Okay, now we have to find the number of possible outcomes for the event A, that is when we get the sum as an even number. Okay, for that let me write the stuff over here. That is A is the event of getting the sum as an even number. Okay, now let me consider very first outcomes. When I add the two numbers, that is the number I'm getting in the first time, the number I'm getting in the second time. When I add them, I'm getting 2. So the sum of numbers in the first outcome is 2. It's an even number. So we can consider that is a favorable outcome for the event A. And when I go to this one, 1 positive 2 is 3. We cannot consider this one because we have to consider the outcome where we get the addition of two numbers is even. So 1, 3 we can consider. Let me write it. Then 1, 4 won't, and we can consider 1, 5, and 1, 6 is not. Then 2, 1. 2, 1 also will not work because when I add 2 and 1, it's 3. 2, 2 can be considered because 2 positive 2 is 4, and 2, 3 will not, and 2, 4 okay. And 2, 5 not, 2, 6, and let's come to the third row. 3, 3 positive 1 is 4. Let me write it. And 3, 3 the third row, and 3, 5, then 3, 3, 6 will not work. Now let's go to the fourth row. So in fourth row, 4, 2 we can consider, and 4, 4, then 4, 6. Okay, now let's go to the fifth row. And fifth row we can consider this 5, 1. Let me write over here. And then we have 5, 3, then we can consider 5 comma 5. Okay, now that's all we have in the fifth row. We can go to sixth row. We can consider 6 comma 2, 6 comma 4, and 6 comma 6. So out of these 36 outcomes, I have displayed the outcomes where we are getting the sum of two numbers as an even numbers. So in all these outcomes, when I add the two numbers in each outcome, the sum is even. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there are 18 outcomes where we get the sum as an even number. Since A represents sum as even, so the number of favorable outcomes for the even A is 18. So okay, now let me write 18 in numerator. So this is the property of getting the sum as an even number. Okay, now let's get the favorable outcomes for B. So B means like the sum of the two numbers must be prime. Okay, let me write the event B over here. Okay, 1 positive 1 is 2. 2 is a prime number, so we can write 1 comma 1. Okay, 1 comma 2. 1 positive 2 is 3. 3 is also a prime number, so 1 comma 2 we can take it. 1 positive 3 is 4. 4 is a composite number, we cannot consider. 1 comma 4. 1 positive 4 is 5. That is a prime number. Oh, sorry, 1 comma 4. Okay, and also 1 comma 5 we cannot consider. Okay, now let's consider 1 comma 6. When I add 1 and 6, I'm getting 7. So 1 comma 6 is considered to be an outcome of B, because 1 positive 6 is 7. 7 is a prime number. Okay, now let's go to the second row. 2 comma 1. 2 comma 1 means 2 positive 1 is 3. 3 is a prime number. So we cannot consider 2 comma 2. 2 comma 3. So 2 positive 3 is 5. It's a prime number. And 2 comma 4, 2 comma 5. Yeah, 2 comma 5 can be considered because 2 positive 5 is 7, which is a prime number. 2 comma 6 cannot be considered. So 3 comma 1 cannot be considered. 3 comma 2, which is add up to 5. Let me write it. 3 comma 2. And also 3 comma 3. 3 comma 4 can be considered. Let me write it. And 3 comma 5, 3 comma 6, 4 comma 1 can be considered. 4 comma 1. And 4 comma 2, 4 comma 3. 4 positive 3 is 7. 7 is a prime number. And 4 comma 4, 4 comma 5, 4 comma 6, no, 5 comma 1, 5 comma 2, 5 comma 2, 5 positive 2 is 7, 7 is a prime number, that is 5 comma 2, 5 comma 3, 5 comma 4, 5 comma 5, 5 comma 6, because 5 positive 6 is 11, 11 is a prime number, we can write 5 comma 6. Okay, 6 comma 1, 6 positive 1 is 7, 7 is a prime number, you can consider 6 comma 1. And 6 comma 2, 6 positive 2 is 8, 8 is a composite, 6 positive 3, 9, 6 positive 4, 10, 6 positive 5, 11, 6 comma 5 can be considered because 11 is a prime number. Okay, so now I got the outcomes where we get the sum of two numbers is a prime number. Let me count it. 1, 2, 3, 4, 5, 6, 7. 8, 9, 10, 11, 12, 13, 14, 15. There are 15 outcomes out of 36 outcomes where we get the sum as a prime number. Okay, let me write it 15. So 15 is a number of favorable outcomes for the even B. Okay, now we have to consider this one, P of A and B. A and B means we have, and means we have to consider both the events A and B. That is, when we pick a particular outcome, the sum of the two numbers must be even at the same time. It has to be a prime because A and B. So A means the sum must be even at the same time. It has to be a prime number. So for that we have to, A and B means that is A intersection B. That is, we have to pick the common element of these two sets A and B. What is the common element of A and B? And so here, according to the discussion we have done, A and B means the outcome must have the some even number and also it's a prime number. So even number, which is a prime number, is 2. 2 is the only even number which is prime. So we just have to pick the outcome in both the sets A and B. So where the sum is 2. So there is only one outcome, that is 1 comma 1. So here the sum of two numbers 1 and 1 is 2, and also 1 plus 1 2, 2 is also a prime number. This is the only outcome we find in common in these two sets A and B. So P of A intersection, the number of favorable outcomes for A and B is just 1. Let me write it over here. Okay, now we have to simplify this numerical expression. So since we have 36 as the denominator for all the fractions, we can take 36 as a common denominator. So now we can add the numerators 18 and 15, 80 positive 15, and here we have negative 1. Okay, we know that 18 positive 15 is 33, 33 negative 1 is 34 divided by 36. Okay, now let's get the common divisor for this 34 and 36. Clearly it's 2. This 2 goes into 34 17 times, 2 goes into 36 18 times. So we get 17 over 18. So 17 over 18 is the probability of getting the sum is even or prime.